NEC 110.26. A2 addresses working space requirements in front of electrical equipment, including service disconnects. This section mandates a minimum depth of 3 feet for the working space. The specific scenario involves a rolling table placed in front of a 30 amps, 480 volts service disconnect. The key consideration is whether the movable nature of the table affects compliance with NEC 110.26. A2. Several options and factors need to be considered. Firstly, the table's mobility is critical. If the table is easily moved and rarely obstructs the disconnect, maintaining the disconnect's current location might be acceptable. However, if the table frequently remains in front of the disconnect, it violates the required working space. Secondly, moving the disconnect is the safest option. Relocating the disconnect ensures constant compliance with NEC 110.26. A2. Eliminating any hazards associated with obstructed access. This option should be prioritized if the table commonly remains in place for extended periods. Thirdly, leaving the disconnect as is viable only under specific conditions. This includes situations where the table is seldom in front of the disconnect or can be swiftly moved when access is needed. Implementing clear labeling and markings on the table instructing personnel not to block the disconnect becomes essential. This option demands increased vigilance to guarantee a consistently clear working space. Fourthly, proper labeling of the table is essential if the disconnect remains in place. A clear warning should be affixed to the table, stating something like "Do not block electrical disconnect" or similar language. This serves as a constant reminder to personnel to avoid obstructing the disconnect. Fifthly, employee training is also important. Employees working near the disconnect must be fully aware of the potential hazards of blocking access to it. They should be instructed on proper procedures to maintain the required working space. Training should emphasize the importance of immediate access to the disconnect in emergencies. Sixthly, regular inspections need to be in place. Routine inspections of the area should be conducted to verify that the working space remains unobstructed and that the table is properly marked. Inspection frequency should be determined based on the likelihood of the table being placed in front of the disconnect. Seventhly, emergency access must be guaranteed. Regardless of the chosen option, the disconnect must always be accessible during emergencies. This might involve ensuring a clear path to the disconnect or having a designated person responsible for quickly moving the table if needed. The recommended approach hinges on the specific circumstances. If the table is often in front of the disconnect for extended periods, relocating the disconnect is the superior choice to ensure NEC compliance and safety. Conversely, if the table infrequently obstructs the disconnect, maintaining its current location may be acceptable, assuming stringent measures are enforced to prevent obstruction of the working space. Additional considerations include, firstly, employee safety. Employees must be fully informed about the potential risks and explicitly instructed not to position the table in front of the disconnect. Regular safety briefings and training sessions can reinforce this message. Secondly, regular inspections must be performed. Conduct routine inspections to confirm that the working space remains unobstructed and that the table is adequately marked with warning labels. Thirdly, emergency access is paramount. The disconnect must always be readily accessible in the event of an emergency. Ensure a clear path to the disconnect and establish procedures for quickly removing any obstructions, including the table. The decision to move the disconnect or leave it as is should be based on a thorough risk assessment. Factors to consider include the frequency with which the table obstructs the disconnect, the potential consequences of delayed access to the disconnect, and the cost and feasibility of relocating the disconnect. If the risk assessment indicates a significant risk of obstruction or potential harm, moving the disconnect is a prudent course of action. Documenting the decision-making process is crucial. Whether the decision is to move the disconnect or leave it in place, thoroughly document the rationale behind the decision. This documentation should include the risk assessment performed, the factors considered, and the measures implemented to ensure compliance with NEC 110.26. A2. This documentation serves as a valuable record in case of future inspections or incidents. Consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. They can provide expert guidance on the best course of action for your specific situation. Their expertise can help identify potential hazards and ensure that the electrical system is safe and code compliant. Consider the physical layout of the manufacturing facility. Evaluate whether there are alternative locations for the table that would not obstruct the disconnect. Repositioning the table might be a simple and cost-effective solution to the problem. If relocating the disconnect is necessary, carefully plan the relocation process. Ensure that the new location meets all NEC requirements for working space, clearance, and accessibility. Use qualified electrical contractors to perform the relocation work. After relocating the disconnect, update all relevant electrical drawings and documentation to reflect the new location. This ensures that accurate information is available for future maintenance and repairs. Consider implementing a lockout/tagout procedure for the disconnect. This procedure ensures that the disconnect is properly de-energized and locked out before any maintenance or repairs are performed on the electrical system. This helps prevent accidental energization and protects workers from electrical shock. Implement a system for tracking and managing electrical safety issues. This system can be used to record any identified hazards, track corrective actions, and monitor the effectiveness of safety measures. Regularly review and update the electrical safety program to ensure that it remains effective and compliant with all applicable codes and regulations. A robust electrical safety program is essential for protecting workers from electrical hazards and ensuring a safe working environment. Provide ongoing training to employees on electrical safety topics. This training should cover topics such as arc flash hazards, lockout/tagout procedures, and the proper use of personal protective equipment. Regular training reinforces safety practices and helps prevent accident. If the table is used for specific tasks, consider redesigning the workstation to eliminate the need for the table to be placed in front of the disconnect. This might involve reconfiguring the layout of the equipment or using a different type of table that is easier to move or store. Consider using a portable barrier or guard to prevent the table from being accidentally placed in front of the disconnect. This barrier should be highly visible and easily removable when access to the disconnect is required. Regularly inspect the disconnect for any signs of damage or deterioration. This includes checking for loose connections, cracked insulation, and corrosion. Repair or replace any damaged components promptly to prevent electrical hazards. Keep the area around the disconnect clean and free of debris. This helps prevent accidental contact with energized components and reduces the risk of fire. Ensure that the disconnect is properly grounded. Proper grounding is essential for protecting workers from electrical shock and preventing equipment damage. Test the grounding system regularly to ensure that it is functioning properly. Consider using a remote-operated disconnect switch. This allows the disconnect to be operated from a safe distance, reducing the risk of exposure to arc flash hazards. If the disconnect is located in a damp or wet location, ensure that it is properly protected from moisture. This might involve using a waterproof enclosure or providing adequate drainage. Install warning signs near the disconnect to alert workers to the potential electrical hazards. These signs should be clearly visible and easy to understand. Ensure that all electrical work is performed by qualified and licensed electricians. This helps ensure that the work is done safely and in accordance with all applicable codes and regulations. Maintain accurate records of all electrical work performed on the system. This includes records of repairs, modifications, and inspections. These records are essential for tracking the history of the electrical system and ensuring that it is properly maintained. Regularly review and update the electrical single-line diagram to reflect any changes to the electrical system. This diagram is a valuable tool for understanding the configuration of the electrical system and troubleshooting problems. Consider using a power quality monitor to track the performance of the electrical system. This monitor can detect voltage sags, surges, and other power quality problems that can damage equipment and disrupt operations. Implement a preventive maintenance program for the electrical system. This program should include regular inspections, testing, and cleaning of electrical equipment. Preventive maintenance helps prevent equipment failures and extends the life of the electrical system. Develop an emergency response plan for electrical incidents. This plan should outline the steps to be taken in the event of an electrical fire, shock, or other emergency. Ensure that all employees are familiar with the emergency response plan. Conduct regular drills to practice the emergency response plan. This helps ensure that employees are prepared to respond effectively in the event of an emergency. Consider using arc flash-rated personal protective equipment when working on or near energized electrical equipment. This equipment can protect workers from the serious burns and other injuries that can result from an arc flash. Conduct an arc flash hazard assessment to determine the appropriate level of personal protective equipment required for each task. This assessment should be performed by a qualified electrical engineer. Provide regular training to employees on arc flash hazards and the proper use of arc flash-rated personal protective equipment. Arc flash training is essential for protecting workers from the dangers of arc flash. Consider using current-limiting fuses or circuit breakers to reduce the severity of arc flash events. Current-limiting devices can help limit the amount of energy released during an arc flash, reducing the risk of injury. Consider using remote racking devices to operate circuit breakers from a safe distance. Remote racking devices can help reduce the risk of exposure to arc flash hazards. Consider using infrared thermography to inspect electrical equipment for hotspots. Hotspots can indicate loose connections, overloaded circuits, or other problems that can lead to equipment failure or fire. Regularly calibrate and maintain all electrical testing equipment. Accurate testing equipment is essential for ensuring the safety and reliability of the electrical system. Consider using a ground fault circuit interrupter GFCI to protect workers from electrical shock. GFCIs are designed to detect ground faults and quickly interrupt the flow of electricity, preventing serious injury. Consider using an automated transfer switch to automatically switch to a backup power source in the event of a power outage. Automated transfer switches can help ensure that critical equipment and systems remain operational during a power outage. Consider using a surge protective device (SPD) to protect electrical equipment from voltage surges. Voltage surges can damage sensitive electronic equipment and disrupt operations. Consider using a harmonic filter to reduce harmonic distortion in the electrical system. Harmonic distortion can cause equipment overheating, reduced efficiency, and other problems. Regularly monitor the electrical load and the system to prevent overloading circuits. Overloaded circuits can lead to equipment overheating, fires, and power outages. Consider using a power management system to optimize energy consumption and reduce energy costs. Power management systems can help identify areas where energy is being wasted and implement strategies to reduce energy consumption. Consider using a renewable energy source, such as solar or wind power, to reduce reliance on the grid and reduce energy costs. Renewable energy sources can help improve the sustainability of the electrical system. Consider using energy-efficient lighting to reduce energy consumption and improve lighting quality. Energy-efficient lighting can save money on energy bills and improve the working environment. Consider using variable frequency drives (VFD) to control the speed of electric motors. VFD can save energy by adjusting the motor speed to match the load requirements. Consider using a building automation system (BAS) to control and monitor the electrical system. A BAS can help optimize energy consumption, improve equipment performance, and enhance building security. Regularly review and update the electrical system to ensure that it meets the current and future needs of the facility. The electrical system should be designed to accommodate the growing power demands of the facility and to support new technologies. Consider using a qualified electrical consultant to provide expert advice on electrical system design, operation, and maintenance. An electrical consultant can help ensure that the electrical system is safe, reliable, and efficient. Staying informed about the latest electrical codes and regulations is crucial for maintaining a safe and compliant electrical system. Regularly review industry publications and attend training seminars to stay up to date on the latest requirements.